Going live. Okay, so here we are. This is 0, this is 0. So what are we doing? We're reading the abacus. Because we're reading the abacus, where it's going to be easy to do. We have 1, this is 1. And then we have 2, 3, 4. So what we just did is 1, 2, 3, and then there's 4. So that's 4. This is what 4 is. Every time the beads are touching the horizontal bar, this is considered 4. Now if you look, we want to know what 5 is. 5 is over here. 5 is that. This is 5. Why is this 5? Because there's none of the bottom beads are touching, so this is 5. If we did this, this is 1. So 1, 2, 3, 4. And then we have 5. 5. Number 5. We all know what number 5 looks like. Number 5. So when we look, okay, so that's 5. And then we have 6, 7, 8, 9. And that's what it is. Hello, hello, good morning, good morning, good morning. So what's after 9? Well, after 9, is 10. That's what 10 looks like. Let's see. 10. 0, 1. That's what 10 looks like. So we have our 1 and our 0. If we notice, we have 11. 11 is 1 and a 1. So because we have 1 and a 1, this is 11. And then we have 12. After 12, this is 13. After 13, this is 14. Then what's after 14? Well, we remove the 4 and then we add the 5. The 5 will always be the top bead, no matter what. So this is 5. This is 5. This is 5. That's 5. These are all 5s. When they're all 5s like this, that means they're being counted. Thank you for the likes. So what we're going to do is we're going to continue how to count. And then let's go backwards. Are we going to go backwards? No, we're not going to go backwards. So I showed you what 1 looks like. When we add the 5, now we have 6. Notice how easily the beads move. So I just did this and all my numbers got messed up. So when we look at it, we have to hold our abacus to make sure that our answers are stable. So if I showed you 1 and I add the 5, now we have 6. If I have 2, this is 2, 1, 2, and I add the 5, now we have 7. If I have 3, I have the 5, now we have 8. I have 4, and guess what? When I add the 5, now we have 9. Notice that all these numbers together is 9. When the beads are touching this horizontal bar, this is what's being counted. Because these are being counted, now I know that this is 9. None of these columns are being counted. So when we look, we have 1 or 1. Well, what's the difference? 1 or 1. It's about place values too now. So when we look, this is our place values. We have our 1s, our 10s, our 100s, our 1000s, our 10,000. So now we have an idea of what we're trying to look at. Why am I here? The reason why I'm here is because I have this dot indicator, this ones indicator. This is my ones indicator, and this one indicator lets me know that this is what the ones is. Just how we count. We count 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9, and then after 9, we have 10. So now we can count by tens. We have 10, 20, 30, 40, 50. Again, remember the top bead is 5. So we have 50, 60. How do I know? Because we have 10 and a 5. Now this is 60. 6, 0. That's what it is. Oh, thank you, Naput. Peanut. Thank you very much. Thank you for the follow. So we have 60, 6 and a 0. And then we have 7. This is not 7, this is 70. 70 because this is a 0. 7 and a 0, right? And then this is 8. 80, 8 and a 0. And then 90, 9 and a 0. And then 100. Giselle, who hurt you? Who cares? Oh, I meant, wow, nice. Really? Don't be mad. Don't be mad. All right. So when we're going to count, because on the abacus, we're going to use the ones or tens or hundreds or thousands or 10,000. When we look, right, these are our place values. And after this, we can do adding, subtracting, multiplication, and division. But it all depends. Good morning, Audrey. Welcome. Thank you. Thank you for the heart me. So we're going to read the abacus again. And when we read it, we have 1, 2, 3, 4, and then 5. After 5, we have 6, 7, 8, 9. After 9, oh, thank you for the follow, Giselle. So this is 9, and then we have 9. This is 99. And then after 99, we have thank you for the follow. We have 999. When we look, all of these beads, when they're touching the horizontal bar, it is now being counted. Because it's being counted, we know that all of these are 9. So if I wrote this, when I write this, I will write this when I find a pen. What does that look like? Well, we have 99,990.99. So if that makes sense. So what we're doing here is we're using these columns as a place values when we write our numbers. Abacus mimics the way we write. And the way we write is less than right. Oh yeah, thank you, Peanut. Yeah. Let me know if you have any questions because Audrey and you are and Audrey, you and Giselle are the only one in the room. So, so the first thing we're going to do again. So what we could do is we can do some looking into read some numbers. So let's read some numbers. So I showed you what the numbers are, right? I showed you what 5 is and 7, and then this is how you read the abacus. Now, what we're going to do is we're going to look at this. No, over here. All right. This is a maze that I created. And with this maze, here is a question. What number do you think this is? Oh, maybe I should make it better. Let me see if I can make it better. So what number do you think this is? Please put in the comment what number you think this is. And if I look at it, I have this number and then I have this number. What number do you think that is? So now what we're doing is we're looking through the maze and trying to understand how to read the abacus. So thank you for the squirrel, Audrey. That's so funny. 52. Yes, this is 52. How do I know? Thank you, S. This is 52. This is a 5 and a 2. Great. So now what I'm going to do is I'm going to find my path and I'm going to go down here. Can we see that? So what's the next number? And what we're doing is we're learning how to read the abacus. When we read the abacus, then we can add, subtract, multiply, and divide. What number do we think that is? Thank you, S. Yes. So we have 1 and we have 7. 5, 6, 7. So we have 17. 1, and then 5, 6, 7. So we have 17. Thank you. Hello, Ethan. And so we're going to go up to here to my other side, and then we're here. Now, what number do we think this is? If I clear it out, thank you, Audrey. We have this, and we have that. What number do we think that is? So if I color it in, we have these two, and then, thank you, S, 5, 6, 7, 8. Peanut, are you okay? You all right? So what we're doing is we're reading the abacus. That is 28. So I'm going to color that in, and I'm going to go over here. Now we have this number. What number? Cute. Thank you, Sasha. Thank you, Audrey. So we have this number, and then that. Oh, I think Peanut left. 91. Thank you, Sasha. Yeah. How do we know it's 91? Because it's 5, 6, 7, 8, 9. I'm stuck on the place values. Okay, hold on. So that's good to know. Where did my... Okay. Maybe that's too much. So place values. We have our 1s and our 10s. When we look... Oh, what number was this? Oops. What number was that? That was 96, 95. So we're at 95. And then, thank you, Miss Hurricane K. Okay. Can we do that? So just like if we have it, let's see, maybe that would be better. So we have a 1, right, in our 10s. And then we have that number, which is our 5s. Yes. Right. Good. So if you notice, 1s in the 10s. Not a problem. Thank you for letting me know. So we have our 1s and our 10s. And what is our number? So we have our number, this one and that one. Sometimes it's easier, because we don't know what it looks like to read on the abacus, right? So what number do we think that is? 11. Almost, almost. It's actually not 21. This is a 1 because this is the horizontal bar, and now this is one bead. 21 looks like this, 20 and a 1. If it was 11, it would look like that. This would be 11. 15 is what I was looking for. Hi, Dory. Thank you. I speak whale. That's funny. It's 15. Why is it 15? Because the top bead will always be the value of 5. The tens will always be the value of 1. Yes, thank you, Audrey. So this is 15. So we have our 1, our tens, and our 5. So we have 15, just as how we write 15. So we have this number. Let's do it again. Let's see if we can do it again. Yes, the top bead will always have the value of 5, no matter what. It doesn't matter what it is. It will always be the value of 5. So if I showed you what that number is, what number do you think that is? So if I have this one, because that's my tens, right? And this, I have that one, that would be my nines. Yes, and yeah, I feel like Thor. Yeah, I'm getting confident with that because thank you. Good job, Audrey. 19. It is. How do we figure it's 19? Because this is 10, right? And this is 5, 6, 7, 8, 9. So we have 9. Yes, thank you. I don't know how to say that. Kai? Thank you. Yes, the top bead will always be. So we are at 20, no, 19. So I'm going to go over here and I'm going to go over here. So what number do you think that is? Um, let's see. I have this and I have that. There we go. And then if I move it this way, and then I have that. So 20, yes, thank you. 20, yes, 29. 5, 6, 7, 8, 9. Exactly. So we have 29, and then what are we going to do? Oh, we're going to go over here. So what number do we have that? Right. If I have my tens, and then this is my ones. Oh, yeah, you got one. Yes, thank you. I don't even know how to say Kai. K? Is it K? Ka. Kia. Yes. That is 18. It's a 5. It's a 1. 5, 6, 7, 8. Kea. Ah, see, Kea. Yes, good job, Peanut. Thank you. Kea. Kea. Kaya. Kaya. There we go. Kaya. Everybody's so, yeah, Kaya. Yeah, everybody's very creative with their names. And I'm like, I'm not very creative with my name. So what is this? Yes, thank you, Kaya. Yes, it is. Because we have 7, 5, 6, 7, and then we have 5, 6, 7 again. So yes, thank you, Sigma. That it's 77. So we have our ones and our tens, and now we have 77. So the number is 77, and then we have this number. What number do we have? What number is this? Let's see if I can make it down like this. Is that right? Okay, we'll do that. We have 2 and then 3. Yes, 23. Hey, Miru! Welcome back! Thank you, Dory. I speaks whale. Yes. Yes. Okay, great. That's 23, and we're going to go over here, and we're almost done. Are we almost done? I think we're almost done. What number do you think that is? So what we're doing again is we're just learning to read the abacus. After we learn to read the abacus, we will then learn how to move the beads and add, subtract, multiply, and divide. What is next? Yes. How do I know? Because this is 3, 1, 2, 3. Yes. And then this is 1. So we are at 31. Yes, good job, Peanut. Good job. Okay, final one. Final one. We have our last one. What is our last one? Whoa. Yeah, good job. Right? Yes, Kaya. Yes, 91. How do I know? Because this is 9 and then this is 1. So when we look, we have our tens. Oops, we have our tens and our ones. So 9, I'm sorry, 5, 6, 7, 8, 9, and then this is 1. And now we're at the top beads in the is up. Yes. So when you do that, that is what 10 looks like, right? 10, 1 and a 0. When we do 11, that's what 11 looks like. When this one, when they're all together, this is now 91. After 91, right? After 91, we have 92. 92. Then we have 93, and then there's 94. After 94, 9, 5, 6, 7, 8, 9, and then we have 95. What's 95? 95 looks like that. That's what 95 looks like. We have our ones and our tens. After tens is 100, right? We have this is 100. This is 100, 101, 102, 103, 104. When we look, if I add the 5, now we're at 109. The bead, the top bead, yes, the top bead is a value of 5. So when we look, you might want to use a nickel to help understand. So when we look, here is, this might be helpful. If you are in America or North America, we have a nickel. A nickel is worth 5 cents, right? This is 5 cents. Because it's worth 5 cents, I'm going to put it down. So now that is what 5 looks like. If I want to add one more, that would be a penny. A penny is a value of 1. When I have a value of 2, right? 5, 6, 7, then I have my money. 5, 6, 7. After 7, right? We have 8. So I'm going to add another penny and then I have 8, right? 5, 6, 7, 8. And then what happens when I have that? That's a 9. So what's going to happen is I have 5, 5, 6, 7, 8, 9. Does that make sense? So when we look, this is what the 5 looks like, right? Because we have the 5, but this is not 5. This is now 50. But every column will be a 5. So this is going to always be 5 no matter what. That's a 5. But if I hide it, right, then it'll be a 5. If I did that. So if I did this, right, this will always be 5. Peanut. Thank you for explaining to me. I'm new here. No, thank you for commenting. Because if I didn't know you were here, I didn't know you'd be struggling, right? It's good that you commented because then I'm not the only one in the room. 500. Yes, exactly. Thank you. So it is 500 because how do we know? This is our hundreds. So this would be 500. We have 500, 0, 0. So when we look, we have our ones, our tens, our hundreds, our thousands, and our 10,000. Good job. Yes, thank you. I don't know what that is. It looks like bubbles, but that's a very good, yes, observation. So the other thing is why am I starting here? The reason why I start here is because I have this dot. This is my indicator. When would the decimal be used? When we're using money, right? So if I wanted 2 cents, this would be 2 cents. Why? Because this is my ones. This is my 2 cents. If I want 10 cents, right? If I have 12 cents, then it'd be like that. But that's because, this is like, say, this is $3.12, right? Yeah. So, and it's interesting though, because we don't see it this way, right? We see it when we write it, but it doesn't translate. So when you look, we have $3, right? This is my decimal. The decimal sits between the ones and the tens. And then we have 10 cents and then 2. Right. Thank you, Peanut. Thank you. So what we're doing is we're learning how to read the abacus and understand that there's a I finally understand now. Oh, good, good. Sen. So now, why do we have another dot here? Well, if you notice, you can choose any dot to be your ones. You could do here is your ones, so it'll be ones and tens. But notice now I don't have any more beats to have the hundreds. So that's why I start in the middle, kind of in the middle. And that's why I would start here. It's kind of nice to have these two here because we use the abacus for money. So you can use it for calculating money if you really choose to. Or you can use your calculator. But this is really, helpful to see the numbers when we look. And then the other thing was what? Oh, every dot is a group. Ah, thank you, Audrey. Yes, the green bead up 100 column. Yes, the green bead at the hundreds column is 100. Yes, please don't forget to tap the screen to show me some love. Show me some love. So what we're going to do is we're going to do our ones, our tens, our hundreds, our thousands, and our 10,000. So exactly right, Peanut. So when I do this, we're going to add the 5. Now we're at 600. Because we're at 600, the top bead will always be the value of 5. So when we look, that'll be the value of 5, and then we had the 1, 5, and the 1. So we did a little bit of learning how to read the abacus. Are we ready to learn how to move the abacus? That's a thing. I didn't believe that was a thing. Thank you for the share. Thank you for the share. Okay. So again, if you're looking for this, do you want to practice on how to read the abacus? Oh, before I go on, we got to do the other one. This was a really cool one that I made. So this was the maze that I created, right? And then afterwards there's a thing called the reverse maze, and I'm like, what, this is cool. So I was thinking about, like, how am I going to do this reverse maze? That's not it. Here it is. Here is a reverse maze. So again, you start from the beginning. And where's the beginning? The beginning is right here. So here's the beginning. But now the question is what am I going to put in this dot right at this box right here? Notice that this is shaded. So because it's shaded, now you know what number you have to do. So what you're going to have to do is find my marker. And because I know this is 68, I need to color in the beads to make it 68. So I'm going to make 60, 5, 6, and I'm going to make 8. 5, 6, 7, 8. So then I'm going to go this way, and then I'm over here. Because I'm over here, I need to know what my next number is. My next number is, why is the blue Y, Wandering Warrior? Why? That's just the way it is. The top bead actually is not, the top bead will always be the value of the value of 5. So it doesn't even matter if it's a blue bead or a brown bead, right? So Wandering Warrior, when you're looking at it, it's always going to be the top bead, and it's just that's the way the abacus is designed. When we look, we have 5, and then we have 1, 1, 2, 3, 4, and then 5, 5, 6, 7, 8, 9, and then we have 10. But because the ones on the bottom are 4. Yes. Yes, exactly. See, Peanut, you are understanding because we have 1, right? If I did this would be 4. 1, 2, 3, 4. Now, when we have the top bead, this will be 5. This will always be 5. So now we can count higher than 5. We have 5, 6. That would be 6. Yes, Peanut, see? And then we have 7, 5, 6, 7, and then 8. 5, 6, 7, 8, and then 9. 5, 6, 7, 8, 9. Exactly. Exactly, Peanut. Wow. That was a really good explanation. Thank you. I appreciate that. Wandering Warrior. Did that make sense? So when we look, it's not about what the color is, it's about the positioning of the beads. It's about the positioning of the top bead and the bottom beads. If you want to talk about it in the what is it? If you want to talk about poetry and poetic, it is these are the heaven beads and then these are the earth beads. Okay, good. Okay, good. Thank you, Wandering Warrior. Let me know if you have any questions. We will continue on. And so that's what this was. And so now what we're trying to do is we're trying to understand what 24 is. I would just color in 20 and then 4. 1, 2, 3, 4. And then it would take me to here. And then now we have 67. So I'm going to color in 60 and then 7. 5, 6, 7. And this one is what I call a reverse maze because you get the maze, right? We show you what the maze looks like, but then you're going to have to find out what the numbers are. Okay, so that's the book, and this is available on the other platform that starts with an A. And you can look for it. My name is Lynette. Thank you. Hello, my name is Lynette. Welcome to my live. If you have any questions, let me know. and we're going to continue on. So this is available there. All right. What we're going to do is we're going to continue on with how to move the abacus. Now, why? Well, one thing is some people have commented that it's very simple. It's very easy to mess up your numbers. I'm like, yes, it is. It's all about attention to detail and about what is it like? I don't know. It's about attention to detail and also making sure that everything's stable. So when you look, I'm Gabby. I'm Gabby. I love to learn new things. Oh, hello, Gabby. I like teaching abacus. I will be purchasing. Oh, okay, great. Oh, but just so you know, this is a standardized abacus. So what does that mean? Every abacus that you see is a standardized. Some person said, well, like, I wish that they were a little bit bigger. I'm like, this is as big as it gets. And so when you move the beads, notice that when you move the beads, you're only going to use the edge of the bead to move the beads. So you actually don't need a lot of force, and you don't need a lot of air surface area, I guess would you say. So when you move the beads, you want to make sure you're only touching the edge of the bead. So when we count it, and I know you can't see it, but when I do it, right, I only touch the top parts. I only touch the edges of the beads. So when I'm looking at it, I do 1, 2, 3, 4, and then 5. Notice the where my fingers are placed. So when I do this, this is about moving the beads now. We have 5. We use our index finger to move the top bead. So we have 5 and then we have 6. So when we look, we have 6. We move the 2 beads like this. But notice I'm touching only just the edges of the beads. So when we move it, we're only moving the edges, right? We're not moving the whole bead, right? We're leveraging the sharpness of the beads. That's why the beads are designed the way they are. Hey, my name is Keith. Yeah, hey, Casey, welcome back. So I'm just talking about how to move the beads because I see that I take for granted that you guys can see more than I think, but I wanted to really make it obvious that when we're moving the beads, we're only moving the top, we're only moving the edges of the beads. Does that make sense? And also notice it's very easy to mess up your answer. So you want to hold it stable and make sure that it's a flat surface. So when we're looking at it, right? And then you notice that I had another abacus. This is a 13 column abacus, and the 13 column abacus works exactly the same as a 7 column abacus. It's just bigger numbers. So because it has bigger numbers, and as size matters, you can have larger numbers. So this one is only ones, tens, hundred, thousands, 10,000. But now what happens here is we can do more than that. If we wanted to, we could do the ones here. And then we would do ones, tens, hundred thousands, 10,000, 100,000, millions, billions, 10 millions, 100 millions, billions, 10 trillions. Billions, 10 trillions, 100, yes, you know what I mean. So it all just depends on what dot indicator you're going to use. If you wanted to, I usually, for the 13 column one, I usually start in the middle because I don't know how many beads I'm going to have to use. So when I start in the middle, it's still the same concept. You just move everything over. And I would understand, how to get it all matched up, if that makes sense. You know what I'll do is probably make a place value thing. Okay, so when we have it, it'd still be exactly the same. It's 1, 2, 3, 4, and then 5. After 5 is 6, 7, 8, 9, and then we have 10, right? Okay, how are we doing? We're all right? Thank you for the hearts and the likes. Okay, so this is about the 13 column abacus. Now, if you wanted to track the national debt, you can use a 23 column abacus. This is a 23 column abacus. Before I forget, these are made out of plastic, right? It's okay, they work exactly the same, but notice it's very easy to move. So you want to use your left hand to stable the abacus. And then this one has been with me for 20 plus years. This is made out of bamboo, I believe. And this one was made out of Japan. Yeah. 23 columns, and it's still the same thing, right? We have our tens, we have our ones, our ones, our thousands, our millions or billions or trillions and so forth. It all just depends on what dot indicator you're going to use. That's all it is. And again, if you notice, these are all the same color. So it's difficult to say. So that's why we call it the top bead and the bottom beads. Or if you want to be poetic, we call them the heaven beads and the earth beads. Now, some people will be asking, well, what about the other abacus? Well, there is another abacus. This is what we call a Chinese abacus. This Chinese abacus works very similar to the Japanese abacus. This is a Japanese abacus. This is a Chinese abacus. It works very similar. The beads are the same. We have the top beads and the bottom beads. We have the top beads and the bottom beads. We have the heaven beads and the earth beads. And when we count, we still count it. 1, 2, 3, 4. 1, 2, 3, 4. And then we have 5. On the Japanese abacus, we have 5. And then we have this. When we have 5 here, we want to do a trade in. That would be 5. So 5 and then 5. We have 6, 7, 8, 9, and then 10. Because this is 10, because this is 5, we would trade it into the top. But because this is 10, we now traded into that. I'm doing money. Is there a way to note that this is 7? Yeah. So if I'm looking at my abacus, this is my ones. 50 would just be that. Or 75 would be this. That would be 75. How do I know? Because this is my ones. Thank you, Felix, for the question. If I choose this to be my ones, notice it's very convenient to have this as my decimals. So if I look at 50, that'd be 0.5. And then here, when I had 75, 0.75, it'd be 0.75. So when we look, this is our ones place. I'm trying to look for my place value. So if we look, so we have our ones, right? We have our ones, our tens, our hundreds, our thousands, our 10,000. This is our decimal. So I'm sorry, our decimal sits between our ones and our tenths. I'm set. Okay. So we have our tenths and our hundreds. I didn't write hundreds, but it is what it is. So when we look, we have 10. So this is what 10 looks like. And again, these are the bottom beads and the top beads. The top beads is the heaven beads. Okay, so that is a little bit about understanding the abacus. All right, what's next? Well, what's next is now we're going to start actually adding and subtracting. When we look at it, right? In abacus world, we actually focus in on the added. What does that mean? Well, in mainstream math, the focus is how to is the answer. But in abacus world, what we do is we focus in on the added. When we look, Yama, welcome back. Thank you. I do appreciate it. And it's funny when people come in and they just, yeah, it's amazing to make the connection on how easy it is to uh to use the abacus. And I think that's what's really energizing. But thank you, Amma. I do appreciate that. Oh yeah, I don't know if you heard, but I do have a new book out for recognizing the 2 digit, and that's available. And I got that going, and I am almost finished my other book, so I'm on book 9. That's crazy. I can't believe how many books I got. So these are all the books I got. Yeah. So we have coloring book. This is the abacus book, and then there's a +5, the +10s, the Halloween one, and the Christmas one. And then we got this one. Thank you so much. Yeah, my collection is growing. So, all right. So going back to how to add. When you notice the in abacus world, what we want to do is we want to focus in on the add-in. When we focus on the add-in, what we're doing is we're understanding what number it is to add. We have the 5, we're going to add the 5, right? We know how to add the 5. Now what we want to do is we want to add the 1. When we add the 1, notice I only want to add the 1 bead. That 1 bead is the only thing that we're going to add. Now why? Because we're adding the 1. We're not focusing on the number 6. We're focusing on the number 1. So when we look, right, we have this one, which is 7. I'm going to add 7 to the abacus. When I add 7 to the abacus and I add the 1, we're going to add just the 1 bead. And that's all I'm doing. And my final answer is 8. And again, we have 2. In every question, every every in the beginning we start understanding how to move the beads. So here we have 5, we add the 5, and we want to add the 2. When we add the 2, all it is 1 2, and we're adding the 2. Alma, did you get to see the post? If not, we can review it. Hey Snoopy, welcome back. Um yeah, Alma, let me know if you have the let's review. Okay, you know what? Let's do that now. I'm not sure if anybody else is here, but since you're the only one commenting, let's do it. So what we're going to do is we're going to understand how to add and how to multiply on the abacus. This one was percentages, and this is more about the concept, right? So one of the things that we're going to do is what was the it was a like what 12% of 64. We could do that, right? So we have 12% of 64. Now when we look, right? When we look, this has nothing. This what? Yeah, that works. Okay, good. Well, hopefully it works. Huh, we don't know. Now, if you notice, 12% is what? When we change this into a fraction, we know that this is a 12 over 100. 100 is equal to 64. Does that make sense? So if 100% is 64, we want to know what this is. So this is algebra, right? What we're going to do is we got to take this and we're going to times it by 64. So we times this by 64. So then what we're going to do is we just multiply it out. Now we have 64 times 0.12. When we count it on the abacus, we're counting 1, 2. We have only 2 digits on the abacus. So 1, 2, and we're doing it. So now 6 times 1, 6 times 1 is equal to 1. Sorry, 6. So 6 is a single digit, so I go back 1 comma, I add the 6. 4 times 1 is equal to 4, so 4 is a single digit. I go back 1 comma, and I add the 4. Right? Now I'm going to start over again. I'm going to start on this side, on the 1. Oh, I don't have enough beads. Oh, that's okay. 2 times 6 is 12. 2 times 6 is 12. So I have my 2, no, 1, and I had my 2. 2, I don't have enough beads to add the 2. What do I do? Why would you just cross multiply? That's what we just did. We are cross multiplying. So when we're adding the 2, what are we going to do? We're going to add the 2 plus the 2 is equal to plus the 5 minus 3. Plus the 5 and then take away the 3. Right? And then, what is it? 4 times 2 is 8. 8 is a single digit. I go back 1 column and I add the 8. So my final answer is 7. 7.68. 7.68%. Yeah. Yeah. So when you're looking at it, and it's been a while since I've done division. No, it's been a while since I've done like fractions and percentages, but this is how I would set it up. And this is just logic, right? Thank you, Felix, for the cap. So I hope that makes sense. So when you look at it, like logically, you would have to think like, what are we trying to do? So we're trying to get a partial. We're trying to get a part of a whole. So the part of the whole, that's how you set up the fraction. Yeah. When I was doing it, I was in the mode of doing fractions all the time. That's what kind of confused me a little bit. All right. So that is the review. And that was in the post. Yep. So let me know if you have any more questions. Okay. So let's go back to the answer would not be a percentage sign. It would be. It would be a percentage. It would still be a percentage. Why wouldn't it be? Because I changed it. That's what 12% is. 12% is 0.12. So I already calculated it into my question. The moment that you divide by 100, it's going to turn into a percentage. Hello, little stories. Thank you for joining. Ashkard. No, Arshad. Yeah. Why is it not a whole number? Because 12% is not a whole number. 12% is 12 of 100. The percentage itself is a fraction. Yeah. Hello. Good morning, Lady J. Okay, good. Okay, good. So, yeah, I mean, there's only 12 of us. I'm not sure if anybody else has any questions, but we can talk about more math. We could talk about abacus. Thank you. Oh, hello. Good evening, Lady J. Yes. Do you have any questions? Can we talk about it? Let's talk about it. Do we have any other abacus questions? So, I mean, I can continue on doing this, but I'm actually quite excited for my next books coming around. I have, yeah, I'm excited for this book, for the beginner books, and this is just about identifying the numbers and stuff. And so I made it into a puzzle. They're all puzzles. There's about 36 puzzles, and they're only one-sided. It's one-sided because I'm not sure what they're going to use to color it in. So, and I didn't want the, if you're using marker, it's going to bleed through. So that's why it is single-sided. But because it's single-sided, it's just easier. And then you can put a cover, like a sheet between it, so then it doesn't bleed to the other one. Yeah. And then we showed you how to do the reverse maze. I don't know if Peanut's still here, but I think Peanut left. Yeah. So I'm building out my other one. Yes, I do have another one that's coming down the pipeline. I just got to create my book cover, and then that will be my how to. There will be a book between it. It actually sits between these two books. So the book that I'm working on right now sits between these two books. It's a minus the 10. So it's minus, I'm sorry, minus the 5. And then I got to work on minus the 10. So right now I have it where I'm working on this on the third book. The third book. Yeah. So then I'm going to fill out my curriculum. And it's going to be a lot of activities like um, tic tac toe. I think I added a lot of mazes and the hidden word and word problems. I had word problems and spin the wheel, and I just got to format it nice, so then it'd be great. Are we okay with that? Wow, that didn't work out well. Okay, when we go through, it is add the 7 and minus the 7. Notice again, I'm only using the edges of the edges of the beads. I'm only going to do this. So when I add the 7, it looks like this. When I take away the 7, it's like this. Notice I'm only using the edges of the beads to move it, right? Hello, Maria. When we look, we have 8. And again, if I have 1, my question is 8. Is there enough to add the 8? Yes, there is. So I'm going to add the 8. I'm going to add 8. Oh, add 8. And there I go. And my final answer is 9. Okay. So now this is a subtraction, right? We have 7, and then we have the 1. We add the 1, and then what we do? We take away the 5. Gotta go talk. Okay, Audrey, we'll talk later. We want to minus the 5. When we minus the 5, notice I'm going to move it away from the horizontal bar. So when I minus the 5, I'm going to take it away from the horizontal bar. My final answer is 3. When we look, it's the same thing. We have 8. We're going to have 8. No, that's not 8. This is 8. And we minus the 8. We just move it all out like that. And now we have 8. So if I have 9 and I minus the 8, it's just taking it out like that. So we have 5, 6, 7, 8. So what we did, we minus the 8. Make sense? Anybody have any questions? So that was how to move the beads. That's all about moving the beads. After we move the beads, we can start going into bigger questions. Any other questions? Any questions whatsoever? Nobody have questions? Come on. This cannot all just make sense to you. All right. So what's going to happen after this? Well, there's a concept that we're teaching the kids. We're teaching the kids how to add a 5. When we teach the kids how to add a 5, how to make a 5, we're going to teach the kids how to make a 5. Okay, we're teaching the kids how to make the 5. Well, we know how to make a 5. We make a 5 is a 1 and a 4 and a 4 and a 1. We know how to do this. Now, why are we doing this? Well, this is a concept and it's great. It's a great fundamental concept, but we actually use this in abacus because we are able to see it. When do we use it? We use it when there's not enough beads. So here's a question that I have. Let's start with the 3, right? On the abacus, I have 3. Now, if you notice, I don't have enough beads to add the 4. Because I don't have enough beads to add the 4, now I'm being restricted. But I can think of my elements. What is my element? I know this concept. This concept is a very, no, that's not what I'm going to do. So what we're doing is we're understanding this concept. This concept is very interesting. Why? Because we can utilize it and make it better. We can level up our abacus. We can level up our numbers. We can make sure our numbers are not freeloaders because I don't like freeloading numbers. So when we're looking at it, we're going to isolate the variable. This is what we're doing. We're going to isolate this 4 because this 4 would be very similar to that 4. So when we look, I want to add the 4. Notice I'm going to utilize this 5. Because I utilize the 5, I need to rearrange my equation. I'm going to take this 1, I'm going to move it over here. I haven't seen a live for a while. Thing! Okay, Felix, thank you. Oh, no. Take care, Thang. Take care, Felix. See you in my next live. Um, uh, Thang, you should be in bed. You should be like resting up and stuff, not doom scrolling. Don't be doom scrolling. Sid Sunday. I won because they will put me on the spot right there. I'm tired of being sick. It was drink a lot of orange juice, a lot of lemonade, honey lemonade. What else? Honey lemonade and what else? Chicken soup. Okay, now I went to the doctor. It's a virus. It, it's always a virus. Yeah, you gotta wait for it to go through your system. Rest up, rest up. Nobody knows what kind of virus. We try to figure it out, but nobody knows. Yeah, but the biggest thing is, as long as I think what they say, rest, right? You sleep and you rest and drink a lot of fluids and a lot of electrolytes, like what, coconut water or Gatorade or something. So before I forget, I'm going to continue on this. So I have my 4. When I add my 4, I'm going to make it equal to 5. Well, when we make it to equal to 5, notice this is not balanced. So we're going to minus the 1. When we minus the 1, what does that mean? We're now going to be able to utilize. I just woke up. I'm going to work, but I can't stay. Oh yeah, go to work. I'll see you on my next live. Thank you so much for dropping by. It was good to see you, even though you're not feeling well. Have a good day. So when we add the 5, we're going to add the 5 and we're going to take away the 1. And those are the directions. Yeah. Those are the directions. When those are the directions, now we know my final answer is 7. So I have 7 is my answer. Yeah, 7 is my answer. So what I just do is I took a concept that we're teaching in school and I'm making it and I'm leveling it up. Oh, 7. So we could do it again, but notice it's become more versatile. When it has more versatile, it's 4 plus 4. Now, if you look, I have 4 and I want to add another 4. Because I want to add another 4, I don't have any more beads to add the 4, but I have this concept that I know. This concept is 4 plus 5 is minus the 1. 4, so what did we just do? We substituted this information into the 4, right? So now what we did is we did a little bit about algebra. Abacus is the gateway to complex math. So when we add it, we have the 5 minus the 1. 5, and then take away the 1. My final answer is 8. So what we're doing is we're not memorizing our doubles. So following this pattern, when add the 3 without any room. Yes! Yes! Exactly! Exactly! That is fantastic. I'm so happy you got it. Yes, that's exactly what it is. Because if these are all the patterns. So when you look, I have this one, which we were talking about. We want to add the 3. When we add the 3, what is the question? The question is, let's do 4. So the question is 4. When I have the 4, I don't have any more beads to add the 4. What do? I can utilize the 5, right? We can do that because we have this concept that we're teaching the children. We're teaching the children how to add the 5. So what we're going to do is we're going to do 3 is equal to 5 minus 2. Exactly what Sebun said. So what I'm going to do is I'm going to plus the 5 and then take away the 2. So my final answer is 7. Again, we don't memorize doubles. We have this concept. So when I have 3 and I take away and I added 3, I'm going to plus the 5 minus the 2. And that's the pattern. But notice now, what does that mean? We can actually do subtraction. Now we have the pattern. We can solidify it. So we do minus 3 minus 2 is minus the 5. Why are we going to do that? Because when the question is 7 minus 3, 7 minus 3, what are we going to do? Minus the 3, we're going to isolate it. We're going to move it over to the other side. Notice if I have 7, I want to take away the 3, I can utilize the 5. I can minus the 5 and add the 2. I'm going to add the 2. So my final answer is 4. Does that make sense, Anubis? So what we were doing is understanding that we have a pattern, because now we have a pattern, we can actually utilize it, and you'll see more. You'll see more. It gets even more. That makes a lot of sense. Yeah, and we don't have to, and we minimize the amount of memorization, right? So when you look at it, we limit the amount of memorization. We only need to know what our pairs are and how to move the beads. So that's why it's beneficial to understand what it looks like on the abacus. When we look, we have 8. We have 8, and we want to take away the 4. We know how to take away the 4. We know we have stuff that we can take away the 4. Minus the 4 is what? Minus the 4 is equal to minus the 5 plus the 1. So instead of memorizing, there is no doubles minus. That's the interesting part. So, but in abacus, it goes hand in hand. There, if you know how to add it, you'll know how to subtract. You just got to do the opposite. So notice, you will notice that there's the pattern. I'm going to minus the 5 and add the 1. I'm going to plus the 5 and add the 1. Minus the 5. Plus the 5 minus the 1, or add the 5 or minus the 5 and plus the 1. Notice this is the number pattern that you're looking at. And every time I see it, I know I'm going to add the 5 or minus the 5. And then we come back and we start looking at our numbers, right? So what we do is we move the beads, and then when we're done, then we take a look at our answer. So that is adding and subtracting the 5. Well, what happens when we need more? This is when we start doing carrying on. Why? Well, again, when we do a carrying on, we carry the one, we borrow, we trade, we group, we regroup, right? So what we're doing, it's so interesting to see math and the patterns. Oh my God, it's amazing. It's so amazing. And it's interesting, right? Because what we're doing, and I was trying to figure out how to make it more of like colorful and stuff. This is what we did when we talked about Bob the Builder. Do we have enough? Yes, we do. Then I showed you the introduction of adding 5, how to make a 5. So now we have this pattern, and all this is 5. And then again, we do this is the, is there enough beads? Yes, we can. The next one we're going to do is the plus tens. And that's what we're going to do right now, is adding the 10. But it's interesting to see how Abacus does it. So when we look, and I broke it out, this is the subtraction table. When I broke it out, this is the number pattern. And we just do the same thing over and over again, which is really interesting. So here is the addition table in a bigger one, right? So if we have 61 and we take away the 4, or we have 66, take away the 4. And it's the same thing over and over again. And these are the number patterns that I don't think we talk about in school. But it's amazing. When I was breaking it out, I was like, oh my God. So here's the thing. What happens if we need more money? More money. What happens if we need more beads? Because we can't just always be on the ones column. We have many more beads. When we look at it, it's the same thing. Let's do 9 and 1. 9 and 1 is equal to 10. Well, what happens? Well, when we add the 9, right, we have 4. There's not enough beads to add the 4. Because there's not enough beads to add the 4, because I'm over here. Sorry, I'm over here. Because there's not enough beads to add the 4, guess what? We see this pattern again. We know this pattern. What's the pattern? Well, we're going to isolate this 9. Because we're going to isolate the 9, what are we going to do? We know 9 is equal to 10, but that's too much. We have to minus the 1. Minus the 1. So what does that mean? 10. 1 and 0. 0, 1. That's the 10. 0, 1. Add 1. And then that's what I did here. Now I'm going to take away the 1. I got to take away the 1 in the ones column. So my final answer is 13. So notice when I add the 9, all I got to do is plus the 10 minus the 1. When I take away the 9, it's minus the 10 plus the 1. So again, this is the number pattern that we're looking at, right? It's interesting to see it physical, a physical representation on the number patterns. Hello, Angel. Thank you for the follow. Hello, Thomas. Do you have any questions? Anubis, any more questions? Are we going to continue on? We're just going to continue on. So it's interesting because why? Now we can make it one step further, right? We can go to the next one. And now we've become more versatile. So we're not just memorizing how to make a 10. We're actually utilizing the concepts of making 10s. So we know that these two are always going to be a pair. So these are always going to be pairs. Hello, Echo. Ah, thank you so much. So it's because I'm talking about the abacus. Thank you, the like. So what we do, hey, Jose, welcome back. So when you look, these two are the pairs. This is a pair. These are pairs. These are always going to be pairs. So that's the one thing. I was doing research on another book, And I'm not understanding why they make 6 and 2 a pair. Cause why? Cause when we look at on the abacus, if I have 6, and my question is, do I have enough beads to add the 2? Yes, I do. I can be like Bob the Builder. I just add the 2. So I don't know. It was just interesting how, even though you're given a blank piece of paper, there's still, it's nice to be able to work with the constraints. So back to here. When we do 3, we have 3. We're going to add 3 to the abacus. When we add 3 to the abacus, I want to add the 9. Because I want to add the 9, what do? I plus the 10 and I take away the 1. I plus the 10 and I take away the 1. So my final answer is 12. 12. Hey, Summer Flip, welcome back. Oh, all right. Anybody have any questions? If not, we're going to continue on. Because there's this thing called two-step equation. Anubis? Anything? Anything? Bueller? My non-sleeping friend. Yeah. Afternoon. Good afternoon. Hey, Rabina, welcome back. I feel like if I'm here live, I'm always, I swear you're always here. I feel like if I'm here, the people that are commenting and all my friends come over to say hi. And I do enjoy that. I love it when you guys come and say hi. Rabina, do you have any questions? How is it going? I'm following with lots of ahas and moments. See, Anubis, just so you know, hey, Carl, welcome back. Welcome to the real world. I always use that line because when people start to see how interesting the abacus is and how it makes it more visual, not good. Oh, you're always so happy and such a great teacher. Thank you, Summer Flip. I really do enjoy talking about the abacus. I still get the two step. Oh, you know what? Let's do it. Well, I was actually, you know what? Good timing, Rabina, because I was going to talk about the two step equations. So, Anubis, are you ready for the next level? We are going to do the next level. What is the next level? So we understand there's the plus, right? We have the plus, and then we do the minus. The minus is the same. Minus is the same. So if we have minus the 9 is equal to minus the 10 plus the 1. When we have 18, we have minus the 9. Now notice again the questions are, do I have enough? The 9. What do? I need to take away the 10. What's 10? 0, 1. Take away the 1. So I'm going to take away the 1 and I'm going to plus the 1. So I'm going to add the 1. So my final answer is 9. Okay, good. Let's do it. Let's do it. Are you ready, Rabina? We're going to do the two steps. Now, why do we have two step? Two step means that we're going to take and we're going to Tetris our way. So that's the actual secret to the whole everything. What does that mean? Every adding and subtraction that you're doing in the whole wide, no matter how big the numbers are and all this and that, I'm letting you know the secret. You just need to know how to make a 5 and you need to know how to make a 10. That's all you need to do. If you know how to do this and you know how to Tetris your way through, everything is golden. It doesn't matter how big the number is, it doesn't matter how small the number is. Well, it doesn't matter how big the number is. It doesn't matter how complicated when you talk about adding and subtracting. When you add and subtract, those are the only things that you really need to do. So here is the one question is one parent was like, "Well, can we just have my child know what um 8 plus 5 is and then 5 plus 8?" No, this is different. Why? Because we're talking about the add-ins. The add-ins are always the things that are the biggest hurdle. Is it the hurdle? It's not a it's the biggest element of the question because it's what makes us understand. So when we look, I'm going to add 8. When I add 8, we know how to add the 8. That's not a problem, right? I'm adding 8. So then my next one is I'm going to add the 5. You know how to add the 5. We know how to add the 5. How do we add the 5? When we add the 5, we know we're going to be plus the 5 is equal to plus the 10 minus the 5. That's the thing we have to do. Plus the 10, 1 and a 0, and then minus the 5. So I'm going to plus the 10 and then minus the 5. So my final answer is 13, right? We did plus the 5 is equal to plus the 10 minus the 5. So that's what we did. Well, the answers are the same, right? Because it's just reversed. Yes, but no. 8 is different. Why? When we add the 5, we added the 5. That's not a problem. Now we're going to add the 8. 8, what do we know? We know we have the 8. Plus 8 is equal to plus the 10 minus 2. Plus the 10 minus the 2. Okay, so my question is do I have enough to minus the 8? No, I don't. So what I'm going to do, I'm going to substitute this information. Now I have this information. I go step by step. I'm going to plus the 10, right? I'm going to plus the 10, which is a 0 and a 1. I'm going to add 0, 1. I'm going to add my 1 there, right? There's my 10. 1 and 0. I'm done with this. Now I'm going to go to minus 2. I'm over here, minus 2. Can I take away the 2? No, I can't be Bob. I cannot take away the 2. So what do I do? Well, this is where the step comes in. Is there enough beads? No. I cannot just add the beads. What do? I have to try to use the plus 5. When I use the plus 5, I know 2 plus the 2 is equal to plus the 5 minus the 3. So that's where this is 2-step. Oh, I got to do the minus. Can I take away the 5? Yes, I can take away the 5. So what do? Minus the 5 is equal to minus the 5 plus the 3. So that's what this is. Minus the 5. No, minus the 2 is equal to minus the 5 plus the 3. So the question is always, do I have enough beads? So now I do. Do I have enough to take away the 5? Yes. So I take away the 5 and I add the 3. So then my final answer is 13. Did that make sense? So we take it one step at a time. We do this first, then we do this. If we cannot do this, then we do this first, and then we do this. So what we're doing is we're building like a pyramid of steps. Just don't get lost. That part I understand. But, do you remember what helped me with last time? I don't. I'm sorry. Do you remember what you helped me with last time? No, I don't remember. I'm sorry. Was it 49 or something? Oh, my answer is 13. One moment then. Yeah. I don't know. Was it like 49 plus 5? Was it one of those? It's still a 2-step. Or was it like 999 plus 5? Or was it 27 plus 24? These are all 2-steps. Anubis, did that make sense? This is the reason why it's 2-step. I don't know if Anubis is still around. Hello. It was a long equation. Was it multiplication? Yes, I'm following. No, it was a 2-step. Was it a big one? I couldn't understand. Yeah, I don't know. I would have to go back. Wait. Okay. I'm still here. Yep. Yeah. Anubis, right? Does that make sense? So that's why it's called 2-step. The reason why is because you combine the 5 and the 8, the 5 and the 10. So it doesn't matter if you notice, right? If you notice, We have a 4, but then the plus 4 is also in a uh, there's two formulas for plus 4. You can either do a plus 5 or a plus 10. But notice if I go down here, I have a 6 and I have a minus 4. Minus 4 can be either minus the 4 or minus the 4. See how it tetrases it weights through? Yeah. So that's why it's like a little like a web, like a little ladder. As long as you know how to be solid in these numbers, in these formulas, then everything is gold. It doesn't even matter how big the numbers are. Yep. I was just thinking like going live is like going on the radio every day. And I find it funny. Like I'm making like these connections, like trying to trying to get the reach out there, but the other thing like, that's what we listen to the radio. And we just listen to the radio and it's the same songs, but it's kind of catchy. And it's just interesting. And I think I need to be one of those. Can you do those? Can you please do those? I'm sorry. I thought you left. What is it that you want me to do? I don't know what questions. I mean, I can think of some. So we have like, I don't know. Oh, these ones? Okay, yeah, we do that. 99 plus 5, right? This is easy. Why? Because we have 99. So we have 999, right? We have 999. We're going to add the 5. When we add the 5 plus the 5 is equal to plus the 10 minus the 5. So now what are we going to do? Well, I like to make sure that we understand. I have this isolator, right? I want to add the 5, but I don't have enough beats to add the 5. So what do? Right? I have this formula minus the 5 plus the. But instead of this way, I'm going to rewrite it. I'm going to do minus the 5 plus the 10, right? So what we're going to do is we're going to minus the 5. We're going to minus the 5. So I minus the 5, right? That's what we did here. And then what do? We have to plus the 10. We add the 10. 0, 1. 0, 1. 1. This is what we're going to do. We're going to add the 1, right? But to add the 1, there's not enough. There's not enough beats to add the 1. What do? Well, I'm back to here. Now I'm here. I need to add the 1. Do you remember how to add the 1? Plus 1 is equal to minus the 9 plus the 10. So all we have to do is minus the 9 and then plus the 10. Notice 1, 0 plus the 10. I can't do it again. So I go back to the drawing board and I go minus the 9 and then plus the 10. So what I'm going to do, I'm going to minus the 9 and then can I plus the 10 here? Yes, I can. So that is what I'm done. That's when I know I'm done with this question. So when I lift it up, my final answer is 1004. That is what we did. So my final answer is 1004. That makes sense. Realize that the service Western math does to visual learners. I know. You know what? It's not just visual learners. It's tactile as well. So I mean, I have these props because I'm trying to explain what it is, right? But I mean, I've been working with abacus for so long. I've been doing abacus for about 20 plus years, and I teach abacus. And what I'm trying to do is I can just go through and be like, oh, so if I had my question, right, 9, all I got to do is 9, right? Take away the 5 and then plus the 10. I know I'm going to do this. So it's a number pattern. You will see the number patterns. So if I had this and I had the 9, if I do it again, it'll be minus the 5, and then I know I'm going to minus the 9. So that's what I would do. But it's interesting, it's interesting to break it down for everybody else. So here's the other question. So the other question was 49 minus 5. So again, we're going to do, I'm sorry, 49 plus 5. So 49 plus 5. Again, what do? This is another two-step. These are all what we call two-step equations. Why? Because what we did is we understood we have these formulas. We understood these formulas. Now what we're doing is we're Tetrising them through. So let's see what this looks like. We have 49, right? 49. Again, we have 49. We want to add the 9, we want to add the 5. What are we going to do? Well, we want to add the 5 is equal to minus the 5 plus the 10. Well, let's minus the 5. And again, what are we going to do? We're going to add the 10. Wait a minute. We cannot add a 1. What do we do? What do? We don't add the 1 here. There's not enough beats to add the 1. We know what to do. We can do the 5. Plus the plus 4 plus 1 is equal to plus the 5 minus the 4. Plus the 5 minus the 4. My final answer is 54. 54. It adds more dimensions to math. I feel like numbers has always been so linear in my brain. Yeah. And that's the interesting part is like we try to in new math, what we try to do is we try to write it all out, but really I think we need to physically. It's called family in the Abacus app I'm using. Yes. Yes, this is the family. This is the friends. The family is the tens. Sometimes it's called big friends and little friends. Sometimes they call it family and friends. I don't know why they call it like that, but it is what it is. But yeah, I'm trying to. So, Anubis, what I'm trying to do is I'm trying to modernize and popularize abacus. So that's why I use the terminologies like isolate the variable, substitution, making a 5, carrying on, trading, grouping, and regrouping. And so what we did with the tens is we did a grouping and regrouping. Yeah, it's called the app that I'm learning. Yeah, yeah. But what's the question? Okay, so the next one was 27 plus 24. 27 plus 24. Oh, oh, that's not a. Okay, let's do that. 7 plus 6 plus 1. So we have 7. Oh, 7 plus 6. We know how to add the 6. Plus 6 is equal to plus the 10 minus 4. So I'm going to add the 6. I'm going to plus the 10 minus the 4, right? Because I know there's not enough beats. I'm going to plus the 10 minus the 4. I'm going to plus the 10, right? 10 is a 0 and a 1. 0 and a 1. Now what I want to do is I want to minus the 4. How do we minus the 4? Minus the 4, we know minus the 4 is minus the 5 plus the 1. So we minus the 5 and we add the 1. That's it. And then plus 1. We add the 1. So my final answer is 14. Yeah, sometimes you get confused when reading the questions anyway. Yeah, I guess I need to buy an abacus now. um, Rabina, sometimes it's easier if you write it out on a piece of paper. Um, I like the apps if you can keep up with it, but in the beginning, I would write it out just to keep track of where everything is. So here, funny. If I had stock in all the abacus in the world, there's going to be this jump because there's a lot of people that are buying abacus, like this one. Okay, okay. While I wait for Rabina, I'm going to do this one. 27 plus 24. I'm going to add the 20, right? I'm going to add 20, and I'm going to add the 4. When I add the 4, what am I going to do? Can I add the 5? No, I can't add the 5. So what do? I wrote it. I don't see it. I don't see the comment. I think I don't know. Maybe do one at a time. Cuz we had that problem. We had that problem and I couldn't find the answer. Yeah, yeah, yeah. Oh, I have it in my live somewhere. So do one at a time. Yeah, we had that problem, remember? So minus plus the 4. Plus 4 is equal to plus the 10 minus the 6. I'm going to minus the 6, I'm going to plus the 10. Again, to plus the 10, there's not enough. To add the 1, I need to plus the 1 is equal to plus the 5 minus the 4. So I plus the 5 minus the 4. And my final answer is 51. If you can't, go to my YouTube and tell me there, because I have my YouTube on right now. Yeah, if you can't do it here, then go to YouTube, because I see it over there. Yeah. So, yeah. Okay. That was one. No, that didn't work. You got to go to YouTube. Or you can go to Instagram, but it'll take a little bit. Or you can go to LinkedIn or Facebook. Go to my YouTube. YouTube is easier to find. Okay. Well, wait. Anubis, do you have any other questions? There's 7 people in the room, and I don't know. I'm only talking to like 2 people. Who else has any questions? Any questions? Welcome to the real world. I do enjoy abacus, and I feel like it's just so interesting because sometimes we just need to have a constraint. I'm just learning and vibing. Ah, that's cool. Okay, we can go more. Um, oh, that was the thing. We can do like multiplication and division. Vibing, vibing. Yeah, I was getting to the point where I needed to do some uh bigger questions because actually in the process of making a introduction to abacus for adults. I thought I was going to be only talking to parents to show the kids, but I think it's coming to a point where I think adults are wanting to learn, and I feel like it's interesting because why? Because I feel like it's interesting because it's like it's like brain gymnastics. Like we don't calculate enough. And so when we look, it's like, doing Sudoku, doing crossword puzzles, doing word searches, all that stuff. Rapina, are you on the YouTube? I don't see you. Okay. Yeah, it's interesting. And so we can go into, you know what? Let's do some multiplication then. While I wait, we'll do some multiplication. So the one thing about multiplication is knowing where to start. So when we learn how to start, what we're going to do is we're going to count our digits. We should memorize our multiplication fact. We need to memorize our multiplication fact. So we need to know everything from 9 times 9. Because we need to know from 9 times 9. Yeah. Yeah, because we need to know 9 times 9. We can do this number. So I don't want to do, let's do 24 times that by 6. So when we do this, we need to know our digits. right? To know our digits, we need to count we need to count our digits to know where we're going to land. The reason why is so then we have our answer. So 1, 2, 3 is where we're going to put our answer. 1, 2, 3. So we're going to be at the hundreds place. Because we're at the hundreds place, we know that now all we have to do is multiply it out. So when we multiply it out, it is 6 times 2. 6 times 2 is equal to 12. I add my 1, I add my 2. Notice on the abacus that we do not need to know where it is and what it is. I do not need to say 6 times 20 is equal to 120. Why? Because the abacus keeps the track for me. Excuse me. The abacus tracks it for me. When I look, I don't need to say, oh, it's 120. I just know that it's 120 because my abacus does it. So what I'm going to do is my next one is 6 times 4. 6 times 4 is 24. Do I have enough? Yes, I do. I add my 2 and I add my 4. So my final answer is 144. I don't know. Rabina, are you still there? Oh, there it is. How can I read it differently? Sometimes I change the order. That's good. Got it. Okay. So Rabina says plus the 6 is sometimes plus the 1 minus the 5 plus the 10. How can I read it differently? Sometimes I change the order. But it's good that you change the order. You just got to get used to it. Why? Because changing the order helps. This is where you get number flexibility. This is what you call commutative property, very loosely, right? Commutative property is a math term only used for addition, but we can use this process for abacus. Because if you look, we want to plus the 6. I'm going to plus the 6. Plus the 6. So the first thing I would do is I would plus the 5. It is I get confused. Rabina says she gets confused. So how would I read it better? How would I read it better? I would take it slower. You know what you could do? You know what you could do is you could put it in brackets like this. I don't know if that would help, right? So we have is it 6 plus 6 is equal to minus the 4 plus the 10. If we substitute it, we can do plus 6 is equal to plus 1 minus 5 and then plus 10. You could do that anytime that you need to do substitution, right? Even with this, if I wanted to plus the 6 is equal to plus 1 plus 5 minus 4. I get confused. Can you make it shorter? The only no, the only shorter you can do is this. This is as short as it goes because this is the fundamental. This is if you have enough to minus the 4. So you show it? Can I show it? Plus the 6. So if I had 7, plus the oh yeah, so it's 7 plus 6. So when I would do it, you might need to get into you might need to start doing this, right? So looking at the question is 6 plus 6. I want to add the 6 to 7. When I add the 6 to 7, what am I going to do? I'm going to do minus the 4. I can't minus the 4. That's what I would do first on the abacus. Yeah. So I would minus the 4, right? So I want to add the 6. I want to minus the 4. So what I would do is I would minus the 4. I cannot minus the 4. So minus the 4 is equal to minus the 5 plus the 1. So I'm going to minus the 5. And I'm going to add the 1. Then I still have to do this. So when I have this 10, notice 10 is a 1 and a 0. I like the concept of multiplying the left first. You just add. No carrying over the extras. Yeah, yeah. So then I'm going to add the 10. Add the 1, add the 0. Add the 1, add the 0. Okay, so the next question is 17 plus the 6 plus 5. 17, 1, and 7. Right? I want to plus the 6. When I plus the 6, can I add 6 here? No, I cannot. So what do I do? I know if I plus the 6, it's equal to minus the 4 plus the 10. Yeah. So I'm going to minus the 4 first. So it's good that you can minus the 4 first, right? I minus the 4. I can't do it. I need to change the color. I'm going to go here. This is where we get minus the 5 plus the 1. So I'm going to minus the 5 and plus the 1. That's what this is. We're back to here. 10, 1, 0, 0, 1, 0, 1. So what does that mean? I just add that. That's all I got to do. So I'm back to here. Now I want to add the 5. I need to add the 5. Is there enough beads to add the 5? Oh, thank you, Thuran. Thuran. Rabina, do you see that? Do I have enough beads to add the 5? All I got to do is just add the 5. And my final answer is 28. No. Hey, MG. Right, exactly. What? Yeah, right. So when you're looking at Rabina, what I would do is I would isolate every column and ask if I can do it or not. That would be probably what I would do. You know what? It is this is the column isolator and it comes with the framework. It's part of my abacus framework. The blue one. The blue one? What blue one? I'm saying yes and no like a kid watches PBS Kids. Yes, yes, it is. 5 is blue. Exactly. 5 is blue. Yeah. Yeah, I made this column isolator because my kid was having problems with seeing too many of the columns, like it was too much for him. So what I did is I would make a an isolator. And so when we look at it, we only, if you really think about it, we only look at two columns at a time, which was really mind blowing. And so I was like, how do I make it better? So then solidify it, it just isolates and simplifies is what we're trying to do. Yes, thank you, MG. Five is blue. Blue is five. Five is alive. I'm alive. Okay, anyways. We're being at nothing. The what? The blue one. Nothing. Yeah. So you're welcome, Tharun. Tharun. Yeah. When I'm looking at the questions like this, I take it one step at a time. That's what I would do. And so yeah. Yeah. I'm just thinking about the multiplication. But it's one of those things like it is a different way of thinking. It is a different way of processing as well. And this it also provides critical thinking, right? Because the question is it's so cute how you learn to teach better from your kid. Yeah, right. Yeah, and I do appreciate all the lives because I've never really had a conversation, about like why. And so I really appreciate everybody who comes in. I really appreciate the questions that happens because I learned it one way. I didn't learn it when okay, here's the thing. I didn't learn it when I was a kid. I learned it when I was old. And we were just taught to memorize a bunch of stuff, but I like to know why am I doing it? And so when I teach how I learned it. And so I'm always asking, why are we doing it? What was the point of doing this? There's got to be a point to doing all of this. So that's why when we were memorizing our doubles, it didn't make sense to me, right? We don't need to memorize doubles, but we need to do is we need to memorize the formulas. We need to memorize the concepts, the core concepts. And knowing how to do the core concepts, it's interesting to see how everything just falls into place. So, but yeah, and it's one of those things like because there's questions, it's always better to figure out a better way to say it. But yeah, thank you for the follow, Anubis. Yeah. And that was a funny thing too. I actually made these little flippy thingies for him. This is my homemade one. I use it. I keep it for my sentimental value, but I used it. I made it out of like some extra cardboard packaging that I had, and so some people said that's really cool, and then I made it into a thing. So I have this available. Um, yeah, it's funny. It's just funny, but I do enjoy like all the conversations and stuff, especially with those that are like, "You're making it too complicated." I was like, "Well, okay." But yeah, we can go into more multiplication. Rabina, are we okay? Did that make sense? Yeah, and then I have like these like worksheets and stuff that I make, but it's very interesting. All right, we can do more multiplication. Yeah, we'll do a couple more, and then right, we'll do a couple more. Let's see. Thank you for the like. We will do. And actually, it doesn't matter how big the numbers are. It just matters on. So if we did 7, 3, 4 times that by 7, 5, 7, 6, we'll do that. We'll do that. Yep, I'm still here, Rabina. I'm going to do some questions. I'll wait. So minus the 4 is the same as my. Yes. Yes, exactly. Minus 4 is exactly the same as plus 1 minus 5. Yes, it is exactly the same. See? Minus the 4, you're not wrong. Minus the 4 is minus the 5 plus the 1 or plus the 1 minus the 5. They are exactly the same. Yes. And so it's the same way when we talk about the tens. Plus the 3 minus the 10 or minus the 10 plus the 3. It doesn't matter. This is where we become number flexible, right? This is where we become flexible in our understanding and our thinking. So when we look, we have the let's say 6, and this is where we were at. Plus the 10 minus the 4 or minus the 4 plus the 10. It doesn't matter. It's not just one way. Oh, excuse me. Okay, so again, we're going. Oh, I gotta get a bigger abacus for this one. Yeah, see? Yeah, no, you're absolutely right, Rabina. She just said, ah, yeah. And so it's all about being flexible and understanding your numbers. That's all it is. The ultimate thing is you're still trying to understand it. Streaming on the profile and it doesn't show up unless the stream is public on by default. It's friends only. I don't know. Okay, so what we're going to do is this: 1, 2, 3, 4, 5, 6. So what we do is we need to understand where we're going to put our abacus. The reason why I'm over here is because now I have a lot more numbers, a lot more digits. I'm going to start from here on my ones column. When I start here, have to go, okay, see you later, Rabina. I will see you in my next live. This is so much fun, isn't it? I feel like learning adult. I feel like adults often miss the joy of learning. Yeah, I believe that too. Um, I feel like we just go through the day in and day out. We learn on our, at work and stuff, but I think this is just kind of some like a hobby, right? Like we don't learn it. Ah, thank you too. Thank you, Rabina. See you later. Bye. Okay. So we're gonna count, and this will be my last one. 1, 2, 3, 4, 5, 6. So we have 6. 1, 2, 3, 4, 5, 6. So this is where I'm going to have my number. This is where I'm going to have my answer. I'm going to start to the left first. So my question is um what's my question? My question is 4 times 2 is equal to 8. I add 8. 8 is a single digit. I go back one column, I add the 8. And then 4 times 3. 4 times 3 is 12. I add 1, I add 2. 4 times 4 is 16. I add 1, I add 6. We all right? So what are we going to do? We got to count again. I'm going to change to a different color because I like different colors. We're done with the 4. Now we got to count again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 7 times 2 is 14. 14 plus the 10 minus the 6 plus the 4. No, wait, 14. Plus the 1 plus the 4 plus the 1. Cannot plus 1. Plus the 10 minus the 9 plus the 4 plus the 5 minus the 1. 7 times 3 is 21. Add my 2, add my 1. 7 times 4 is 28. I add 2 and add my 8. We're done with 7. Now we're going to 6. And we go one more down, right? 1, 2, 3, 4. 1, 2, 3, 4. So we're here. I'm just trying to find a different way. Okay, we're here. 2 times 6 is 12. I have my 1, I add my 2. I add my 1. There's not enough. Plus the 10 minus the 9. I add my 2. There's not enough. Plus the 10 minus the 8. 6 times 3 is 18. Plus the 1, plus the 8. There's not enough to plus the 8. Plus the 10 minus the 2. 6 times 4 is 24. I add my 2. I add my 4. So my final answer is 111,384. That's my final answer. I think it's right. I have to check it. I have to check it. I always have to check it. 2, 3, 4 times that by 4, 7, 6. Yes, perfect. That is correct. All right. Anybody have any questions? Anybody have any questions? Anubis, you all right? I'm happy. I'm so happy I ended up here. Oh yeah, that's great. That was wrong. Okay. So if there's no other questions, I am going to head out. Yeah. I don't know if Thang is still here. He was supposed to go to work. And Thomas. I don't know if Thomas is still here. Sen. Okay. Great. All right. If there's no other questions, I am going to head off. No. Oh no. I'm not going into work. I'm too sick. Oh. Yeah. I don't get everybody else sick. It just stay in bed. Just go get some rest, Thang. Yeah, if you're too sick since Sunday, that's a crazy one. If it's that bad. You know what I mean? Yeah. I've been resting listening to you. Ah, okay. Trying to learn. Yeah, it's slowly getting better though. Okay, good. Good. I wonder if your taste buds, if you ever lost your taste buds. She says, "Oh my goodness. 7 to 14 days. That's crazy." Okay, that's crazy. Yeah, upper respiratory. Oh, that sucks. You know, upper respiratory. I don't know. It could be like the allergies and stuff. And so like when the winds pick up, I actually start wearing my mask and fevers. Yeah, I could see that. Yeah, I don't know. I mean, because we can use mask, I would just go around the town with my mask on because I don't want to be coughing everywhere. But I know that's a tough one. Um yeah, I don't know if that's a thing, but I would wear my I'm gonna have to mask up. I went to Sabra. Yeah. Yeah, but even I got sick on Sunday. Yeah. Yeah, I mask up when the winds pick up so my allergies don't kick in. And now it's such a common thing that people don't care. So unless you're somewhere in the other states that don't like it. Um I'm very fortunate I'm in California and it's very common in my area. We're in a very oh, I don't care or not care. Yeah. In my area it's predominantly Asian, and so a lot of the people it's just one of those things like it doesn't matter if you wear a mask or not. So, I'm not taking my sickness so they can complain. Yeah. Exactly. Exactly. Yeah. Um but yeah, even when you are healthier, I would still mask up whenever I can. Not all the time, but it's usually when the winds pick up. That's what I meant. Anubis. Oh, hey, Anubis. Thank you for sharing. Have a good day. Yeah, have a good day to you too, Anubis. I figured out how to go stream everywhere. I gotta get back. Yeah, honestly, I love that part of COVID. Yeah, yeah. It was interesting to be able to just sit back a little bit and just kind of regroup a little bit. I know we were running around. Don't have to smile, block smells. Yeah, that's true. I liked honestly I liked COVID because it really stopped our lives. And so we were running around with like because I have three boys and we were always in like soccer and all these things. And it was so difficult to like just catch our breath. And we were able to catch our breath and we did a lot of like family we did a lot of like board games. Not me, Sally. I was still at work. Oh, I'm sorry. Yeah, I mean, I still had to work, but I was able to work from home. That was the good thing about that. And then the company's not doing so well just because of the path and stuff. And so they laid me off. So this is what I'm trying to do. I'm trying to I'm trying to kick this up. So we'll see. Hey, Phoenix, thank you so much for liking the live. Now I'm just chit-chatting. It's not very often I get time to chit-chat. So, but I do appreciate you sticking around. But you should rest. I hope well, I hope this works for you. I hope so too. I hope so too. I have a few books. I'm on book 9 right now, so I'm going to publish another book. And then I have another few more books to finish out the curriculum. And then my next plan was to make every grade an abacus version. So I was going to do each grade, like grade 1, grade 2, grade 3, as an abacus version. So we'll see. You've helped a lot of people understand and love the abacus. Yeah, I'm resting to take my meds. Yeah. Yeah. Go rest up and I'll see you in my next live. Thank you so much for dropping by. And I do appreciate you just kind of hanging out and stuff. But yeah, go rest up. It's the blue light. The blue light's not good for you. I'll see you in the next live. I'll see you in the next live. Have a good one. Take care of yourself.